RedChip. We build investor audiences for small cap companies, retail and institutional. 33 years, thousands of clients. We are experts in messaging. National TV ad campaigns, investor webinars, digital media, reaching hundreds of thousands of investors. RedChip. We do it well, we do it right, we do it big. RedChip. Call us or email us today.
In progress.
Hello, and thank you for joining today's event with Calidi Biotherapeutics, which trades on the New York Stock Exchange American under the ticker CLDI. With us today, we have Eric Poma, Chief Executive Officer of Calidi. We will begin with a brief presentation in a moment, then we will answer your questions. Users may submit a question at any time by using the Q&A tool at the bottom of the Zoom window. Before we begin, please allow me to read this safe harbor statement. This call may contain forward-looking statements within the meaning of the Private Securities Litigation Reform Act of 1995. All statements pertaining to future financial and/or operating results, along with other statements about the future expectations, beliefs, goals, plans, or prospects expressed by management, constitute forward-looking statements. Any statements that are not historical fact should also be considered forward-looking statements. Of course, forward-looking statements involve risks and uncertainties. I now turn the webinar over to Eric. Please go ahead.
Thank you, and thank you to RedChip for this opportunity. I wanted to spend a little bit of time today talking about Calidi and what we're so excited about that's happening at the company. We really do believe we're engineering the future of genetic medicine here. I'll show you how we're moving forward in cancer, but also how this technology can really apply to potentially other diseases outside of cancer. I'll reiterate what was just said in the sense that I will be making forward-looking statements here. I want to start by just kind of grounding us where we are right now. There's lots of different modalities available in oncology. We know that there's still huge unmet medical need in oncology, though, so the space is still always looking for new mechanisms of action, new ways to go after tumors. We've seen that viruses can have a role here, but to date, this has been limited to what we call intratumoral or local administration. What that really means is you inject a virus directly into a tumor and the virus can replicate and destroy tumor cells that way. We've seen fairly good success here. Amgen pioneered this space 10 years ago with the approval of T-VEC for certain types of melanoma, but there's been a lot of exciting activity recently here. CG Oncology just submitted their BLA for bladder cancer, some very exciting data there. Candel is moving towards a BLA finding in localized prostate cancer, and Replimune has shown some really promising data in melanoma, and it looks like they'll be moving forward with a submission as well. Again, all this is limited to intratumoral, right? In bladder cancer, that's via intrathecal administration into the bladder. Candel is directly injecting into the prostate. Replimune is directly injecting into melanoma sites. The problem with intratumoral, as exciting as this is that it's highly limiting. Most patients have metastatic sites that are not accessible to intratumoral injection. So most patients aren't eligible for this. But the reason there's so much excitement here is, again, as I said, this represents a new approach to oncology, and it's a new approach along two axes here. One, a very potent and unique way of killing tumor cells. So it works differently than chemotherapy or some of the other targeted therapies that are out there, so the tumor may not be resistant to it. And then two, it's creating a very profound immune signal in the tumor microenvironment that can allow for immune recognition. It's extraordinarily potent. It is transient, though, and I'll touch back on that in a minute. But this is kind of state of the art today, is that we've seen lots of good examples of success with intratumoral or local delivery. But the question is, can we get to systemic therapy, right? The problem here has been when people try to inject viruses directly into the serum so that they could go throughout the body and get to these metastatic sites. As you might imagine, they're viruses, they're seen as foreign by the immune system, and they get cleared very, very quickly. Before they can ever really get to the tumor, they're getting cleared by the immune system. This has been a problem that Calidi's been working on for the last decade here. We've been working on a way of creating viruses that would evade the immune system, get to the tumor sites, even these metastatic sites that can be deep in the body, destroying those tumors. And then we've wanted to go one step further and deliver genetic medicine along with that viral replication. This is, again, what Calidi's been working on for the last 10 years. And with the red tail virus, we think we've really gotten there. So again, we built this, what I call the red tail scaffold here. We've built this step by step over the last decade. We started with vaccinia virus. There's lots of advantages to vaccinia virus. It has a natural tropism towards tumor cells, so it gravitates towards going to tumor cells. It's very potent and lytic when it's inside tumor cells, and it doesn't integrate into host DNA, so there's no potential for transformation. It also is a really large virus, so you can load it up with genetic payloads, genetic medicine payloads, and we thought that was really important. One of the big insights that Calidi has had here is that vaccinia virus has been studied a long time. It is the smallpox vaccine going back to Jenner, but when it's infecting an individual, 99% of the form of the virus that's created is what we call the intracellular mature virus. Less than 1% is the envelope form, the EEV form. And the reason that's important, the EEV form has this second envelope that it takes from a host cell to kind of ensconce it, to cover it. And that envelope is very good at shielding the virus from immune clearance. In fact, if you have an infection with vaccinia and it goes to other organs or other tissues in the body, that is because the EEV form is able to circulate through the body, avoid immune detection, and start an infection in a distal site. That is what we want, right, in terms of designing an oncolytic virus, something that can avoid immunity, get to distal sites in the body. So for the first time here, we've been using the EEV form. We've got some patents around this. We've been able to select for a strain that really makes EEV form at high levels and manufacture that. That's a really deep insight that's happened with Calidi, is this idea of using the EEV form. We then did a second step where we wanted to ensure that the virus only replicates in tumor cells. This is key from a safety perspective. You don't want the virus replicating in normal tissue. If you have a virus that's going to go everywhere, you don't want it replicating in normal tissue. So we made a series of changes, again, genetic engineering to the virus so that it will only replicate in tumor cells. So this is the EEV form, protected from immune clearance. We've made a series of knockouts here, where in the bottom left, you can see that the parent virus here replicates in lots of different tissue types like ovary and lung and brain, as well as tumor. But we've made a series of iterations here, ultimately culminating in the red tail platform, the RT3KO number 2, where you only see replication in tumor cells. That replication in tumor cells is extraordinarily potent. You can see in the chart in the middle here that just about every solid tumor cell line we've looked at, you get excellent replication and cell kill here. So we've taken that EEV form, we've made it, it's already specific to getting to tumor cells, but now it can only replicate in tumor cells. This gives us a really nice safety advantage. We wanted to go one step further on this idea about preventing immune clearance. So the EEV form is resistant to clearance, but there's still some level of clearance happening via complement. We know that. We, again, further genetically engineered the virus to express CD55. That is a normal human protein that blocks complement. So there's lots of literature on this. I encourage you to look at it, but it's very well understood that CD55 expression blocks complement. Normally, vaccinia virus does not express CD55, does not express CD55 in its envelope form. But we've now created this envelope form with CD55 expression, kind of belt and suspenders in terms of avoiding immune clearance. And you can see this kind of visualized in the cartoons here, that the normal form is the IMV form that's not protected against clearance. We're using the EEV form, which is less than 1% of what you typically see in an infection, that has some level of protection against immune clearance. That's how the virus normally spreads through the body. And then we've gone one step forward and engineered high levels of CD55 expression. And you can see on the bar graph here, this is exposing virus to complement in human serum. The IMV form, 80+% of it is cleared almost immediately by human serum, by the complement in human serum. The EEV form, depending on which cell type you use, and again, we've kind of optimized which cell type you use, you can present about 50% of that clearance. But then when you add CD55 expression, that is really inert against clearance. Like you're preserving the majority of the virus here from immune clearance. So this is what we're really excited about. This we think is the first to have an EEV CD55 expressing form that's engineered for systemic delivery. The last piece we wanted to do here, we really like vaccinia virus's potential to have genes inserted into it that can be expressed in the tumor microenvironment, that can be expressed in tumors. Vaccinia is excellent in terms of having a large capacity for insertion, and then it's very, very efficient at expressing those genes when it replicates, much more so than smaller DNA or RNA viruses that lack a lot of the transcription translational machinery and the ability to turn off host translation. So we think vaccine is an excellent model for this. So we wanted to include a payload that would really build on not just the lytic activity of the virus, not the ability to just destroy tumor cells, but I mentioned earlier that when that happens, you get this profound but transient immune signal. We wanted to build on that immune signal. So the first payload we're doing here is IL-15 superagonists. So if you know the space, IL-15 cytokine is an extraordinarily powerful growth factor for activating both NK cells, so the innate immune arm of immunity, and CD8 T cells, the kind of adaptive and memory arm of immunity. IL-15 is very, very good at activating both of those. And we're using a form of IL-15 cytokine called IL-15 superagonist. This is just some mutations are made to the IL-15 cytokine to just enhance its activity. This has been tested clinically. This is what we're using as our payload here. So IL-15 superagonist. Why are we so interested in this? There's a really interesting approval of an IL-15 superagonist called Anktiva. It was approved for the treatment of non-metastatic bladder cancer. And I mentioned earlier that bladder cancer is really interesting because you can directly inject medicine into the bladder. You get extraordinarily high concentrations that are in a small volume. That's what's happening with Anktiva. They dose 400 micrograms per kg into an empty bladder with 50 mils of saline. That's a concentration of 80,000 picomolar. They've seen excellent activity just by introducing IL-15 superagonist into localized space where they can give really high concentrations. They saw 62% of patients with a complete response. The majority of those patients were disease-free for over a year. So that data has been really exciting to the space. Again, giving a high concentration in the tumor, able to get these really good results. The problem with IL-15 superagonist has been if you try to give it in a metastatic setting, again, where there's tumors throughout the body, they have to drop the dose substantially because you can't just activate the immune system everywhere. And their serum concentrations with systemically delivered Anktiva are roughly 20 picomolar or less. So you're talking about a 4,000 drop in dose. And to date, Anktiva in non-small cell lung cancer and some of the other solid tumor types that are metastatic that they've looked at has shown less activity. So we think this is a great opportunity for us. We think we can express huge levels of IL-15 just at the tumor site. So you have the potential to deliver very high concentrations, just like you see in bladder cancer, but now you can do that at metastatic sites. And the reason I say we think we can do that as part of 401, I'll show you the data in a minute, but the idea here is with 401, you give it systemically, the virus migrates towards metastatic tumor sites. Because it's the envelope form, because there's CD55 expression, it's not getting cleared. It gets to those tumor sites, it replicates, destroys them by replicating, but it also primes the immune system to come in and start clearing remaining tumor cells. In addition, it's expressing IL-15 superagonist now, so it's building on that immune priming mechanism to really turbocharge the immune system to recognize, both from an innate and an adaptive standpoint, to recognize tumor. So this we think is wholly unique. Why are we so excited about this? This is an example of one of our early animal models here. We're using a syngeneic murine model here where, and I'll show you more of the data, but this is first just looking at what happens when you inject directly into a tail vein here so that the virus is systemically delivered. What you see is that you get extraordinarily high levels of IL-15 superagonist. If you look at day 6 in the tumor, IL-15 superagonist is at 62,000 picomolar, so very similar to the 80,000 picomolars I talked about in breast cancer, in the bladder cancer with Activa. But you're seeing essentially no IL-15 superagonist in the liver, in ovary tissue, and lung, and plasmas. It's 3 orders of magnitude lower than what you see in the tumor. And you may be looking at this and saying, well, that's at day 6. You have these really high volumes, but those seem to disappear by day 17 and day 21. I'll show you in a second. That's because the tumors disappeared as well. So you're getting very, very high levels of local concentration of IL-15 superagonist. It's not really anywhere else. If you give this to an animal that doesn't have tumor, again, virus only replicates in tumor, you have very negligible levels of IL-15 superagonist. So we're really excited about this ability to just drive IL-15 superagonist expression in metastatic sites, but not anywhere else. And here's an example of what that means. In this model, if you don't treat the mice, they die within the first couple of weeks from this aggressive cancer. If you give them the red tail virus that doesn't express IL-15 superagonist, you can slow that progression. You can cure 1 of the 10 animals, but fundamentally the disease takes over. But when you give these animals CLD401, which is the red tail virus that expresses really high levels of IL-15 superagonist at the tumor, we cure 80% of the animals. Right. Again, this is that kind of 1-2 punch where you have the lytic effect of the virus directly destroying tumor cells, but whatever escapes that is now subject to this immune prime and IL-15 superagonist prime of the immune system, so the immune system can come in and clear out the remaining tumor cells. So this is what we're really excited about. Again, we're on track here. We plan on filing the IND to go into patients by the end of next year, quickly starting a phase 1 study in a basket of solid tumors. So this would be in patients who have progressed on all available therapies and have a limited life expectancy, but we're looking at non-small cell lung, which is the largest tumor type out there, triple negative breast cancer, melanoma, some other tumor types. And again, what's interesting here is a lot of times you have to wait many years in development to understand if your compound is more active than what's out there. Here, there's nothing like us out there. We'd be in patients who have no other available therapies. And if we see responses early in phase 1, I think it would validate that we can give the drug systemically and it can get to metastatic sites and have activity. So there's the potential to understand very, very quickly if the drug is working or not. It's not an approval, but it's validating the bulk of the platform we built here. We think that can happen very quickly and that we can very quickly demonstrate a first-in-class, best-in-class modality in oncology. I'll show you in a little bit how we're thinking of going outside of oncology. But again, I think that's a unique opportunity where you can very early and quickly, very early in clinical development, validate a brand new platform. If you're familiar with the company, a lot of what I'm talking about may be new to you. The company has undergone a pretty important strategic shift here. Just in terms of history, the company went public via de-SPAC in the 3rd quarter of 2023. It was left with a poor balance sheet and a lack of institutional investor base. The board brought in a new management team. I joined 6 months ago. Our CMO joined around the same time. We also appointed a new chairman of the board here. The whole focus now is on the RedTail platform. We're in the midst of updating the website. We're not doing the focus now is on RedTail, not the stem cell based work we were doing before, but really focused on RedTail. We did a lot of work to get debt off the balance sheet. We've reduced operating costs going forward. We're looking at spending 70% of every dollar on R&D costs, and that's going to go towards advancing 401 as rapidly as possible. The data I'm showing you has come out within the last few weeks here, presented at SITC mainly. So this is a new story. We're pivoting to this story. We're out there. We're proselytizing it to investors, to analysts, to banks, and to pharma. So this is a big kind of pivot and turnaround story here. There's more beyond this. We think that the RedTail platform can evolve. Again, we're really excited about 401, the tumor tropism, the fact that it only replicates in tumor cells, the fact that it can be given systemically because of the envelope and the CD55 expression on the envelope, and then the fact that it's carrying this really exciting payload of IL-15 and able to create really high concentrations of IL-15 at the tumor site, We think it's hugely exciting. We're also looking at what else can we do. We are getting better at understanding how to program the membranes so that you can go after specific targets on a cell. We're seeing that there's the potential to have activity in some highly proliferating cells, i.e. activated immune cells, and we're making some engineering changes to kind of facilitate that. That would open up the space of autoimmune, where you could have a new way of destroying autoimmune cells, but also delivering a payload that is immunosuppressive in that environment of active disease. And then we're looking at additional payloads here to impart. We're looking at a host of other things that we can do here. So we think the technology itself is extraordinarily robust, and we're really excited about what we're seeing here. Again, we think there's going to be lots of data coming out from now until end of next year when we open the IND and start clinical studies, and we're kind of spreading the message around this kind of new approach for the company. So with that, I'll stop the presentation, and I'm happy to go to questions here. Let me look at these questions. Can you elaborate on how the RedTail platform differentiates itself from other systemic viral therapy approaches in oncology? There has been some other work, mainly at academic sites, showing that systemic viral therapy can get some good results, early results in cancer. But the big difference here is those approaches have been based on just dosing so high that you try to swamp the immune system and get some of the virus through. That comes with its own toxicity issues and some of its own problems. Here, we think our perspective around having this envelope form with CD55 expression is wholly unique. This idea that instead of trying to overwhelm the immune system, you're trying to evade it, we think is very unique here. We also think the IL-15 payload is an extraordinarily interesting payload. And in fact, one of the questions here is, how does the IL-15 superagonist payload enhance the immune system compared to other cytokine-based therapies? I think what I tried to allude to earlier, I think the real excitement around IL-15 superagonist is that you're activating both T cell and NK cell. The patients we treat, most of them will have gone through immunotherapy, which is T cell based. One of the major mechanisms, if not the major mechanism, of immunity to or resistance to T cell based therapies like Keytruda or Nivo is that the tumor cells shed HLA, or they mutate beta-2 microglobulin, so they can no longer present antigen and be responsive to T cells. Interestingly, those cells are extremely susceptible to NK cell mediated kill. NK cells are constantly on the lookout for cells that have lost HLA expression. So activating both arms, including the NK arm, we think is really, really exciting here. Another question, what are the key milestones investors should watch for leading up to your IND filing in 2026? Again, as I said, we'll be putting out more and more data on both CLD 401 at major meetings like AACR, ASCO, SITC, and we'll also be putting out additional data on what else the platform can do. Interesting payloads like BiTEs, interesting opportunities outside of oncology like autoimmune. Could you share any insight from your recent preclinical data presented at SITC and how it informs your clinical strategy? Again, we've been really excited at how high the level of IL-15 superagonists we're driving in the tumor microenvironment is. It speaks to a really profound NK cell engagement. That has not been something that you've seen in oncology yet. There's lots of examples of engaged T cell activity, but really engaging and activating NK cells has been harder to come by. The concentrations we're seeing are akin to what you see with the only good example of this, which is Anktiva in bladder cancer. And I think this speaks to taking, a real excitement around the idea that you could have activity in a patient who didn't respond to T cell activating therapy like Keytruda or became refractory to a T cell activating therapy like Keytruda. So we think that this concentration and mechanism is really unique and exciting in those kinds of patients. Are there any strategic partnerships or collaboration in the pipeline to accelerate development and commercialization? All I'll say here is that we do believe we have something extraordinarily unique with incredible potential here, and that always garners interest from pharma. So I would just say stay tuned, and we'll continue to update here. What is your long-term vision for Redtail? Do you see applications beyond oncology, such as autoimmune or infectious diseases? As I said, we're starting to see that we can better target the virus to non-oncology cell types and starting to see ways that we can get additional replication outside of oncology in something like an activated B or T cell. We think there's huge potential there. Will CLDI be launching any new advertising campaigns in Q4 to raise awareness and investment? We're taking a pretty robust approach here. We're working with RedChip to reach out to investors. We're going where investors are. We're going to be present at as many meetings and conferences as we can. So this is a huge push for the company to make sure people understand what we're working on and what we're doing. Last question here. Can you talk about specifics of metastatic non-small cell lung cancer? Which metastatic tumor CLD401 can target? Is CLD401 patient population the same or different from Activa population in non-small cell lung trial? This is a really good question. Again, we're getting very intrigued by this notion that a metastatic non-small cell lung cancer patient who's progressed on other therapies will have progressed on T-cell therapy like Keytruda or Nivo. Again, as I said, we think a major mechanism of resistance to that is that they will have shed HLA or had mutations in B2M to prevent antigen being presented. So here we think that looking at those kinds of patients, we expect to see a potential for response there that's really different than what you've seen with other IO approaches because of this NK arm. So that's a subset of patients that we find really interesting. And again, it's a quite a large subset of non-small cell lung cancer patients. Somewhere around 40 to 50% of them will have HLA loss or beta 2 microglobulin mutation. But again, for us, that's a really, really interesting subtype here. So I think that's the extent of the questions I have, and that's the presentation. So I'll happily turn it back to Craig here.
Thank you very much, Eric. We'll wrap up here, but before we go, here's how you can get more information about Calidi Biotherapeutics. You can call us at 1-800-RedChip. You can also email us at cldi@redchip.com. Please visit RedChip's investor information page for Calidi Biotherapeutics. It's cldiinfo.com. There you can view and download the investor presentation and fact sheet and sign up for news alerts on Calidi. Thanks again to our many participants, and thanks